Okay. So for this review, I've just prepared a couple of problems that we can work through. I can't promise that my review will cover everything that will be on your upcoming exam, but I think it should touch on a good portion of it. Okay. If you guys have any questions at any time, feel free to post in the chat, or I think if you have the option to unmute yourself, you can also speak through your microphone as well. Okay. Okay, with that, I guess I'm gonna go and get started. So I've got a problem up right now. This is the first problem that I have prepared. Can I zoom in? Okay, there you go. Okay, all right. Let me see if this will work. Okay, I guess this is good enough. So I'll also just kind of say one thing before I start working is, so my laptop doesn't seem to be working as well as it used to. So I hope there won't be any technical issues, but if there are, please bear with me, okay? All right. Okay, so here's the first problem that I have. So what we have is we're given 2 points, point A. Okay. So A is the point 2, 5. And then we're also given point B, it's the point -4 and -1. And we're given that these 2 points form a diameter of a circle. So here I'm just going to get a rough sketch of this picture. So we had the point 2, 5. So let's say maybe that's 2, 5. That's the rough estimate there. And then we have the point -4, -1. Maybe be about there, I think, in my picture. So these 2 points, they form the diameter of a circle. So in this picture, the circle would maybe look something like that. And then we have a series of questions about this circle. So part A is asking for what are the coordinates of the center of the circle. So to get the center of the circle, the center should be the midpoint between points A and B. Okay. And so then I think you guys have learned a formula for the midpoint between 2 points. So what you do is you kind of average your 2 points together. So what we're going to do is we're going to add the x components and the y components of our 2 points. So for the x components, we're going to do 2 plus -4. So let's do 2 minus 4. And then we're going to also divide by 2. So we're kind of taking the average. Likewise here, add the 2 y coordinates, so 5 plus -1. And then again, divide by 2 because you're getting the average. Okay. And if we simplify that, oh, that's weird. Okay. Okay. So we simplify that. So 2 minus 4 is -2 over 2, which is -1. And here 5 minus 1 is 4. 4 over 2 gives you 2. So this point -1, 2, that would be the center of our circle. Okay. All right, after that, we're also asked what is the radius of the circle. So to get the radius of the circle, I guess there's a couple options you have, but oh, geez. Okay. This is kind of weird. Let's reset. Okay, there we go. All right, so yeah, for part B, looking for the radius. So for the radius, what you can do is you can calculate the distance between point A and the center. Let's call the center C for now. You can also get the distance between point B and the center as well. That will also give you the radius. You can also just get the distance between A and B and then divide that distance by 2. And again, that would also give you the radius, okay? So you have like a lot of different ways of thinking about this part. Here, let me just calculate the distance between points A and C is what I'll do. Jeez. Okay. All right, and then if you guys remember, the formula for the distance between 2 points is the square root of, okay. And then what we're going to do is we're going to take points A and C that we found. So here's A is the 0.25. C was our center. So let's just mark it down here for reference. A is 2.5. C was the center, so it's -1, 2. Okay, so to get the distance between A and C, we're gonna get the difference between the X and Y components. So when we get the difference, we'll do maybe 2 minus -1. I'm gonna square that, and we're gonna add to that. Then we'll do the difference between the Y coordinates of 5 minus 2. Then we're gonna square that as well. And then all of that in the square root, that will give us the distance between A and C, which should be the radius of the circle. Oh, geez. Okay. There we go. So here, 2 minus -1 is 3, so it's going to be 3 squared plus 5 minus 2 is another 3. Okay. So 3 squared is 9, so this is 9 plus 9. That will give us the square root of 18. And I don't know how important it is, but if you wanted to simplify this, you could say that 18 is 9 times 2. And then you can simplify this further. This is equal to the square root of 9, which is 3, times square root of 2. Okay. So then the radius of the circle should be either square root of 18, or if you simplify it, you could also write it as 3 root 2. Okay. All right, and then just again, if you guys have any questions, you can post in the chat or just speak up with your microphone. Okay. All right. Okay, so we got the radius of the circle. Now, part C asks us to write out the equation of the circle in the standard form. Okay, so let's look at that part next. So first, let me write out kind of the equation of a circle in the standard form. So this is what the equation of a circle looks like. Okay. So in this equation, as you can imagine, r is the radius of the circle. And then h and k are the coordinates of the center of the circle. Okay. So we've calculated the radius already. We know the radius is square root of 18. And then we also got the center of the circle as well earlier. So the center of the circle was -1 and 2. Yeah, just wanted to confirm that. Okay. So then if we just plug in the numbers that we found for the radius and h and k, the equation for this circle would be x minus h, so x minus a -1 squared, plus we have y minus k, where k was 2 squared, and then that's equal to the radius squared. Now the radius is square root of 18, and then we're going to square that. Okay. So if we kind of simplify, this is x plus 1 squared plus y minus 2 squared, and then here square root of 18 all squared would just be 18. Okay, so this would be the equation of our circle in standard form. Okay. All right, so now we have the equation of the circle. So there's a couple more parts to this problem. So the last two parts are checking if the circle will intersect the x-axis and checking if the circle will intersect the y-axis. So at least based off my picture, it looks like it should intersect both of them. So let's see if the math confirms that. Okay. So let's do parts D and E for finding the x and y intercepts. All right, so to figure out what the x and the y intercepts are, so for the x-intercept, so to find the x-intercepts, what you want to do is you want to plug y equals 0 into the equation of the circle. Okay. And this is because the points on the x-axis will have a y-coordinate of 0. Okay. So here's the equation of the circle that we just found. So I'm going to plug in 0 for y. Okay. And then let's see if we can solve for x in this equation. Okay. So we still have x plus 1 squared here. Okay, now this is -2 squared, so that's going to become +4 equals 18. I'm going to move the 4 over to the other side. So that will leave us with x plus 1 squared equals 14. So now, if we sort of square root both sides, we're going to get two possibilities. So we have x plus 1 could be +14, or it could also be, positive square root 14, or negative square root 14. So plus or minus the square root. And then you can solve for x by subtracting a 1 from both sides. So x will be -1 plus or minus the square root of 14. Okay. So then here we're finding two x-intercepts. So there's one x-intercept where the x-coordinate is -1 plus the square root of 14. And then for the x-intercept, remember the y-coordinate is 0 for points on the x-axis. And that's why we plugged in 0 for y earlier. And then we found another x-intercept, which is when x is -1 minus the square root of 14. And then again, for the x-intercepts, the y-coordinate is always 0. Okay. So then these would be the x-intercepts. So then in our picture, that would correspond to these 2 points here. So those would have been the x-intercepts that we found. And then it looks like we're going to find 2 y-intercepts as well. So let's do the math and let's find out what they are. Okay. So to get the y-intercepts, it's very similar procedure. For the x-intercepts, what we did was we plugged in 0 for y to get the x-intercepts. So for the y-intercepts, we're going to plug in x equals 0 into the equation of our circle. And again, reason why we do that is because the points on the y-axis will have an x-coordinate of 0. Okay. Right. So then here we have the equation of our circle, and I'm going to plug in 0 for x. That's going to give us just 0 plus 1 squared. Okay. Plus, and then we had y minus 2 squared equals 18. And what we're going to do here is we're going to solve for y. So here this is 1 squared, which is just 1. I'm going to subtract 1 from both sides. So I'll get y minus 2 squared equals 17. And if we square root both sides, there's 2 possible solutions here. Y minus 2 could be plus or minus the square root of 17. And then if we add the 2 to the other side, that gives us y is 2 plus or minus the square root of 17, okay? So we found 2 x-intercepts, one where the y-coordinate is 2 plus the square root of 17, and then another one where the y-coordinate is 2 minus the square root of 17, and then for the y-intercepts, the x-coordinate is going to be 0. Okay. So then here, this would be the 2 y-intercepts for our circle. Okay. So that kind of completes like the first problem that I had prepared. So I'll pause real quick and just ask if you guys have any questions. Am I moving too fast or anything like that? Oh, thank you, thank you. I'm very happy to hear that. All right, great, great. Okay. All right, good. Okay, so in that case, I'm going to go ahead and move on to the next problem that I had prepared. Oh, okay. And then at this point, I'll kind of just say something before I dive into this problem. So I'm using OneNote right now, but I'm using OneNote online because I was having issues with sharing my OneNote application. So it's a little bit different. So that's why if you see me like struggling a little bit with like trying to write something or whatever, it's just because I'm using OneNote online, which I don't usually do. But I had to do it today because for some reason my OneNote application itself kind of wasn't working. Okay. So here's the second problem that I had prepared. So we have this function, it's 1 over x squared minus 5. And a couple of things we want to do. First is we want to find the domain of this function. So to get the domain of this function, The domain is the set of all values for which your function is defined. And here, when you have a fraction, you have to be concerned with where the denominator might be 0. Because when the denominator is 0, that is going to be undefined. So what I'm going to do first is I'm going to take a look at the denominator. I'm going to find where is it equal to 0. So I'm taking the denominator x squared minus 5. I'm setting it equal to 0. And here we want to solve for x. In this case, it's a pretty simple one, so we can move the 5 to the other side. And then if we square root both sides, we get x with plus or minus the square root of 5. Now for these 2 points make our denominator 0. And so our function is going to be undefined at these 2 values. Okay. Now, for any other value of x, though, our function will be defined because we won't have any issue with dividing by 0. So the domain is going to be pretty much all real numbers except for these 2 x values that we just found. So here, sometimes I find it helpful to draw like a visual. So here, this is going to be like the real line. And there's 2 points that we found, negative root 5 and positive root 5. And these 2 points should be excluded from the domain. Maybe I'll draw it like this. And we want to exclude these 2 points from the domain because our function is not defined at these 2 x values. So to express the domain using interval notation, here we see that the domain will consist of the interval from minus infinity to minus the square root of 5. So that's like everything on the left here. It's also going to include, so I'm going to do a union symbol. And then it also includes everything between minus square root of 5 and positive square root 5. And then lastly, the domain should also include everything here on the right. So I'm going to do another union. And then we're going to include everything from square root of 5 off to infinity. Okay. Now I'm using parentheses here for these intervals. So I remember that the parentheses means that you are excluding the point from the interval, the endpoint. If I wanted to include one of these points, I would use like a bracket instead, okay? But in this case, I want to remove these points, so that's why I'm using parentheses to exclude them. Okay, so that gets us the domain of this function. The next part to this problem. Let's see here. Okay, it's not so much the fact that we have a square root or that x is a square root. So really, whenever you have, whoops. There you go. Yeah, so whenever you have a fraction like this, to find the domain, you would start by setting the denominator equal to 0. So you set the denominator equal to 0 and you solve for x. And regardless of what numbers you get when you solve for x, those numbers need to be excluded from the domain. So your domain would be like everywhere except for the points where the denominator was 0 in this case. Okay. Yeah, so it didn't really matter if these were square roots, if they were like really nice whole numbers, whatever those numbers were, you would need to exclude them from the domain. Okay, right. So then I kind of touched on that a little bit, but so if we did brackets, that would mean that, remember that this means that you're including these points. Whereas when you use parentheses, that means that the endpoints are excluded. And I want to remove these points from the domain. And that's why I need to do parentheses to make sure that they are being excluded, okay? Okay, all right. Okay, so part B is also a pretty simple question, I think. So it's asking us to just find the value of f of 2. So I think most of you know how to do this, right? So to calculate f of 2, what you want to do is you want to plug in 2 for x, okay? So the function was 1 over x squared minus 5, and we're just going to plug in the 2 for x, so it's 2 squared minus 5 in the denominator. Okay. Let me simplify this real quick. So that's 1 over 4 minus 5. So 1 over negative 1, which you would simplify to be just negative 1, okay? All right. So for the domain, we are removing only these 2 points, minus root 5 and root 5. Every other number, including the numbers in between the two of them, are good though. So that's why we have this middle interval here, because the numbers between minus root 5 and root 5 do belong in the domain. So only the two numbers minus square root of 5 and square root of 5, only those two numbers are being excluded. And they're being excluded because those two numbers make the denominator 0, which would make the function undefined. Does that clarify things? Yeah, and then maybe just to also clarify one more thing. So I know students sometimes get this a little bit mixed up, but so here, this is like representing like an interval, right? So this is representing the interval of all the numbers between minus root 5 and root 5. The parentheses means that we're excluding the two endpoints, okay? So this is not the coordinates of a point, okay? I know the notation looks the same, but here, this notation represents an interval. It's not like the x and the y coordinates of a point. I know students often get that mixed up. Okay. All right. Let's see here. Let's take a look at the next part. So part C. Okay, so part C is asking for the coordinates of the y-intercept. Okay. And we talked a little bit about this in the first problem, but if you're looking for the y-intercept, so for the y-intercept, you'll find that by plugging in 0 for x, because where it intersects the y-axis, that's where x is equal to 0. Okay. So in this case, what we would do is we would just take our function f and evaluate it when x is equal to 0. Okay. So the function was 1 over x squared minus 5, and we're plugging in 0 for x. Okay. So in this case, that will simplify to be 1 over negative 5, which is the same as negative 1/5. Okay. So then we get one y-intercept where x is 0 and the y was negative 1/5 then, okay? Then the last part to the problem, it wants us to find the values of x, for which f of x is 1 over 11. Okay. Okay, so our function was 1 over x squared minus 5. So we have this equation 1 over x squared minus 5 equals 1 over 11, and we want to solve for x, okay? So to solve for x, what we can do right now, one thing we can do is if we just sort of cross multiply. So let's multiply x squared minus 5 to here, and let's multiply the 11 to here. So that's going to give us 11 equals x squared minus 5. Then in this case, what we could do is we could add 5 to both sides. So 11 plus 5 is 16. And then we could square root both sides, and there would be two solutions. So x could be plus or minus the square root of 16. And square root of 16 is 4. So we have two possibilities for x. X is either plus or minus 4, okay? So then these would be the values of x for which our function was equal to 1 over 11, okay? All right, so any questions about this problem? Okay. All right, so in that case, let's move on to another question then. So let me see what problem number 3 was. Okay, that's a similar question. Let's take a look at this one though, because it maybe looks a little bit more complicated. Okay, yeah, so similar question. Let's take a look at part A, which is finding the domain. All right, so just as before, we have a problem when the domain is, or sorry, when the denominator is equal to 0. Because when denominator is 0, that is undefined. So let's take the denominator of our function, which is x minus 3. We're going to set it equal to 0. In this case, it's a pretty simple equation. Solve for x, we get x is equal to 3. So for this one value of x that we just found, f is going to be undefined when x is 3. For all other values of x, though, there is no issue with our function. So the domain should be all real numbers except for x equals 3. So visually, it will kind of be like the number line, but just with the number 3 removed from it. And then in interval notation, that means the domain would be everything from minus infinity up to 3. And I don't want 3 to be included in the domain, so that's why I have to use parentheses here. And then we also have everything from 3 to infinity, so we're going to union the interval from 3 to infinity. And again, using the parentheses on the 3 to make sure that I'm excluding it from the domain, okay? I guess also just a quick note. So infinity and minus infinity should always have parentheses on them rather than brackets, because infinity isn't like a real, like an actual number. So you can't like actually include it since it's not like an actual thing that you can include. Okay. All right, is that good? Okay, all right. So let's see here. Let's take a look at part B. So it's kind of the same as before. So we're going to calculate f of 2. So to calculate f of 2, that means you want to plug in 2 for x. So we have 2, plug in 2 for x, plus 1 over. And then again, plug in 2 for x, minus 3. Let's simplify that. So we have 4 plus 1 is 5, over 2 minus 3 is negative 1. Right? And then 5 over negative 1, you could write that as just being equal to negative 5. Okay, good. All right, now part C is asking for the values of x for which f of x was equal to 7 this time. So what we'll have to do here is we'll have to take our function, which was 2x plus 1 over x minus 3. We're setting that equal to 7, and we're trying to solve for x. Okay. So to solve for x, what we'll do first here is we'll multiply both sides by x minus 3. So that will just move the x minus 3 over to the other side. And ultimately, to solve for x, we want to get all of the x's on one side and everything else on the other side. So to do that, let's distribute the 7 next. So if we distribute the 7, we're going to get 7x. And then 7 times 3 is 21. So that's equal to 2x plus 1. I'm going to subtract 2x on both sides. Let's also add this 21 over to the other side, okay? So if we do that here, the 2x's cancel, so you're left with 7 minus 2 is 5x's. And here the 21's cancel, and 1 plus 21 is 22. Okay. And so if we divide both sides by 5, we get one possible value for x, so x is 22 over 5. So in this case, we have one value of x, for which the f of x would be equal to 7 then, okay?
I have a question.
Yeah. Uh-huh.
Okay, so before we started, I kind of did it like how we did the other one, and I like multiplied it, like I like cross multiplied with it, and a
Uh-huh.
similar answer. Is it
Okay.
possible to do that? Like, is that
Uh,
right?
I think that would work. Maybe it depends on exactly what you did, but if you're thinking of sort of the cross multiplication, when you have something like 7, you can always write it as a fraction by thinking of it as 7
Right.
over 1. So then when you do cross multiplication, it should yield the same result because you'd have 2x
Okay.
plus 1. Yeah, times 1 is 2x plus 1 still. And then you'd have 7 times x minus 3, okay?
Okay. Thank you.
Yeah, all right, good. All right, anything else? Okay, cool. Let's see here. There was one more part, which was here it's asking for the x-intercepts this time. Okay. So remember for the x-intercepts, that's where the y is equal to 0, okay? Now, here, when we're dealing with functions, remember that the function itself is representing the y-coordinate. So when we want to plug in 0 for y, that means we're actually going to plug in 0 for f of x itself. So in the equation where we had the function is f of x is 2x plus 1 over x minus 3, what we're actually going to do for the x-intercept is we're going to replace f of x on the left with 0. Okay. And the reason why we're doing that is because the function represents the y-coordinate. Okay. And so we plug in 0 for f of x. So we have 0 is equal to 2x plus 1 over x minus 3. Okay. And then we want to solve for x here. So to do that, we'll multiply both sides by x minus 3. You can think of it as cross multiplication again if you want. Okay. Now when we do that, of course, 0 times x minus 3 will still be 0. So really we just have 0 equals 2x plus 1. And then we'll solve for x, so we're going to subtract 1 on both sides, and then divide both sides by 2. So we get x is negative 1/2. Okay. So that means that the x-intercept, the point itself, would be the x-coordinate will be negative 1/2. And then for the x-intercept, the y-coordinate would have to be 0. Okay. All right, is that good? Any questions? Okay, all right. So let's go to the next question that I have. Let's see what it is. Oh, okay. So here we've got this function at f of x. So I'll maybe write it up if it's not too clear. So f of x is 3 minus 2 times the absolute value of x plus 4. And what this question is asking us to do is it's asking us, at least in the first part, to graph this function, okay? All right, so looking at this function here, so this function, it's a parent function. I think you guys use that terminology. But parent function is the absolute value function. Okay. All right, and do you guys know what the absolute value function looks like?
Usually a V, right?
Yeah, it's a V shape. So the absolute value function looks something like this. At least that's the graph of it. All right. So what we want to do in order to graph our function f, we want to, I guess, understand how the 3 and the minus 2 and the plus 4, how all of those things are affecting the graph of the absolute value function. Okay. So do you guys know how each of these numbers are going to affect the graph? Tell me, what does this 3 do to the function or to the graph? Do you guys know? Okay, all right.
move it up by
Yeah, the 3 is a 3 is a vertical shift here. Okay. So it's going to shift up by 3 because we have like a plus 3 here. How does this minus 2 affect things? What does that do to the graph?
It vertically stretches, right, and reflects across one of the axes.
Okay, yeah, I guess there's maybe 2 things to that actually, yeah. So the multiplying by 2, as someone noted just now, gives it sort of a vertical stretch by a factor of 2. Okay. But when you multiply by negative, that also has the effect of kind of flipping the graph upside down, or reflecting about the x-axis, as I think they put it. Okay. So this reflection about the x-axis is because of the negative sign in front of the absolute value. Okay. So I'll say it's because you're multiplying by negative. What does this plus 4 inside the absolute value do to the graph?
Horizontal shift left.
Yeah, so the plus 4 on the inside gives you a horizontal shift. And for the horizontal shift, it's kind of like maybe opposite of what you think. So here, when it has a plus 4, that's actually going to shift it to the left by 4 units. So yeah, that's good. Okay, so we have all these different things going on. What order should we perform these 4 kind of operations in though on the graph? Does the order matter? If so, like what specific order should we do these in?
The shift first and the stretches second.
When you say the shift first, which shift are you talking about? Or maybe you're just referring to both of them.
I think they're interchangeable, are they not? If not, then I would guess vertical. Not vertical, horizontal. Horizontal. Right, horizontal.
Okay.
Inside the brackets.
Okay, yeah. So the way that I kind of think about like what order should we do these kind of for like transformations in, I kind of think of it sort of based off the order of operations. So to me, the horizontal shift would go first because that plus 4 is kind of inside the absolute value. So it's kind of like inside of parentheses. It would kind of have like the highest priority. After that, when you think of order of operations, multiplication would come next. So this multiplication by -2 would give us the reflection as well as the vertical shift. Here, I don't think the order matters that much. But I'll do the vertical stretch too, maybe the vertical stretch first because you multiply by 2. And then after that, you multiply by negative. So I'll maybe do that one next is kind of what it looks like. Now, remember that addition is kind of like, or addition and subtraction are kind of last when it comes to the order of operations. So that plus 3 at the end would be like the last thing that takes into effect, that gets or goes into effect. Yeah, okay. So that's kind of the order that I would do each of these transformations in. So starting with the parent function, this absolute value graph. Okay. So what I would want to do first to get the graph of f is I'd want to do a horizontal shift by 4 units. Okay. So let's try to do each of these one at a time. So we're going to shift it to the left by 4. Okay. So now this V sheet that we have is going to start at -4 rather than at 0. Okay. The next thing we'll do is we'll do the vertical stretch by a factor of 2. Okay. So that means every point is going to be raised upwards by like twice the height, if you will. So it will look maybe something like this. Okay. So that is the vertical stretch by a factor of 2. Okay. And then what we're going to do next is the reflect about the x-axis. So that's going to be the next transformation that we do. Okay, so let's try to draw that picture here. It's -4, and we're going to reflect it, so it's going to be upside down now, so it's going to look something like this. Okay, kind of compared to the original. So reflecting from the red graph that we had after we applied the vertical stretch. Okay, so maybe like that, and then we're just reflecting it. And then the last thing that we had to do was the vertical shift up by 3 units. So then instead of the vertex starting at the x-axis here, we're going to shift it up so that now the vertex will start at 3. Okay. -4. And then again, it's going to open downwards. So then here, this is kind of a good sketch of what the graph of our function f of x would look like. Okay. All right, so let's pause for a moment there. So if you guys have any questions, go ahead and take the time to ask. If not, then I'll move on to the rest of the problem. Yep, I am recording it right now. So later tonight, I'll upload the recording to our YouTube channel. And then I'm going to send out an email to everyone in the class with a link to the video. Okay. All right. So then let's see here. So that's kind of the graph of f. Yeah, no problem. Let's see here. Let's look at the parts B and C. So asking for the domain and the range of this function. Okay. So what would the domain of our function f of x be? Okay. Well, in this case, the function f of x was kind of like an absolute value function. For absolute value, the domain was all real numbers. So likewise for our function f of x, its domain is also going to be all real numbers, so it's defined for all values of x. Okay. There's no like denominator that you had to worry about being equal to 0. So there's something that you really need to worry about for f. So the domain will just be all real numbers in that case. Okay. So to say that the domain is all real numbers using interval notation, you could say that the domain is everything from minus infinity up to positive infinity then. Okay. Now, as for the range of the function that we have, okay. So remember that the range is the set of all the y values that the graph contains, if you will. So fortunately, we kind of already got a picture of the graph here. And you can see from the picture of the graph that the highest y value on the graph is positive 3. Okay. And then it takes on every other y value below 3. So like from negative infinity up to 3. Okay. All of those y values are on this graph. So therefore, the range of f of x, would be all real numbers from minus infinity up to 3. And here I'm going to use bracket on the 3 as well. The reason why I'm using bracket is because 3 is included in the range of f. Okay, since that y value of 3 is part of the graph. Okay. So minus infinity to 3 and a hard bracket on 3 to include it. All right, any questions about that? Okay. And then just let me see here. So then for the last part of this problem, I guess we kind of answered it in getting the graph, but how does the graph of f relate to the graph of this parent function, the absolute value function? So we kind of described it here. So the graph of f is the graph of g, except there's a horizontal shift to the left by 4 units, followed by vertical stretch by a factor of 2, followed by a reflection about the x-axis, and then lastly, you have this vertical shift up by 3. So if you apply all of those 4 kind of transformations to the graph of g, that would give you the graph of f. Okay. Okay. All right, let's see what my next problem is. Okay. Okay. And so here in this problem, we have a piecewise defined function. Okay. So that's what we call this type of function here. So the idea is like this function has been defined in pieces, if you will, okay? So specifically, the formula that you use to calculate f of x, we have 4 different formulas for this example. And the formula that you use will depend on the value of x that you are plugging in, okay? So these intervals tell you which formula to use depending on the value of x that you're trying to plug in. Okay. All right. Now, before we, well, actually, let's do a couple of these questions in part B first, and then we'll take a look at part A after that, I think, okay? So part B, just to get a better idea of, how this function works. So maybe I won't do all of them. Let's maybe do like the odd ones. So I'll do maybe 1, 3, 5, and 7, okay? All right, so in this case, let's take a look at the first one where we're trying to calculate f of 0. Okay. Okay, so to calculate f of 0, so we're plugging in 0 for x. So I'm going to look at these intervals here, and this interval includes 0 for x. So that tells me that I need to use this formula to calculate f of 0, okay? So we have, in this case, f of x is 4x minus 1. And we're plugging in 0 for x, so it's 4 times 0 minus 1. So that's 0 minus 1, which is negative 1, okay? Let's say if we wanted to do f of 4 next, so part 3. All right, so in this case, to calculate f of 4, again, first I'm going to look at these intervals. I'm going to figure out which one contains 4. So in that case, 4 is between 3 and 8. So it falls in this interval. So because 4 falls into this interval, I want to use this formula for my function. So notice that there's no x's to plug in to this formula. It just says that f of x would be equal to 5. So in other words, that just means that f of 4 will be equal to 5 as well then, okay? Looking at maybe part 5 now, which is calculating f at negative 1. Okay. So again, I want to look for an interval that will contain negative 1. Okay. Now here, this is x less than negative 2. So that doesn't work because negative 1 is larger than negative 2. But then this interval is, jumps up to 0 to 3. So negative 1 is not in that interval either. And in fact, negative 1 is not in any of these intervals actually, okay? So what does that mean if negative 1 is not in any of these intervals? That means that f of negative 1 is going to be undefined then. So here we would maybe write d and e does not exist. Okay. Since the function is not defined when x is negative 1, according to these formulas and these given intervals. Okay. And then maybe if we look at the last one, just to get a better feeling for how this works. So this is f of 3. So to calculate f of 3, I want to find which of these intervals contains 3. Okay. Then notice that this interval here, it goes up to 3, but it does not include it because this is a strictly less than 3. Okay. But here we have 3 less than or equal to x. So this does include x equals 3. Okay. So therefore, we want to use this formula for f of x, namely f of x being just equal to 5. So 3 falls in that interval, so therefore f of 3 would be equal to 5 as well then, okay? All right, so any questions about what I did there just now? Okay. Then to look at the domain, okay. So the domain of f is kind of given by all of these intervals here, okay? So f is defined to be this when x is strictly less than -2, okay? So for everything before -2, so that'll be -infinity up to -2, our function f is defined, okay? And then I'm going to do union. And next, over here, we see that f is also defined when x is between 0 and 3. 0 is included, so I want to do a bracket on the 0. Here, the 3 is excluded, so I'll maybe do parentheses on 3, like that, okay? I'm going to do another union, and next we have f is also defined on this interval from 3 to 8. Okay? 3 is included, so I would use brackets on the 3. I'll exclude the 8 here because this is x is strictly less than 8, so it's not included. So parentheses. And then we're going to do one more union here. And then here we have x is strictly larger than 8. Okay. So strictly larger, so I'm going to do parentheses to exclude the 8. And then we just go to infinity, so this is just anything larger than 8, okay? Okay, so we just kind of used each of these intervals that were given in this definition of f here to get the domain. Okay. Now, there's one kind of simplification that you can make to this answer. I don't know how necessary it is. My feeling is it's probably not super important, but there is one simplification that you can do, which is when you look at these two intervals that we kind of had in the middle. Okay. So this one starts at 0, it goes up to 3. But then we're adding to that, and then here we're including 3, right? So since we're including 3, that kind of fills in this hole that we had from the first one. And then it goes up to 8. Okay. So here, really, we see that the entire interval between 0 and 8 is contained in this part. So instead of starting at 0, stopping at 3, and then continuing at 3 and going to 8, you could put all of that together in one interval and just go from 0 straight to 8 altogether. The 8 is actually not included, so actually this would be like an open hole here. Okay. So that would be another acceptable answer for the domain. Here, all we did to get this answer is we combined these two intervals into like one larger interval. Okay. All right. Any questions about that, or just like anything from this problem? All right, let me see what my next problem is. So let's go on to this one here. Okay, let me see if I can figure out how to zoom in. I was trying to zoom in earlier, but I couldn't quite get it to work. Oh, there you go. Now that works. It wasn't working earlier. Okay. Okay, so this problem is asking us to check whether a given function is either even or odd or both or neither. Okay. All right. So I kind of wrote out what the definitions are for what it means for a function to be even or odd. Okay. Okay, so here this is sort of an algebraic definition of what it means for a function to be even. So to be even, if you replace x with minus x in the function, if that gives you the original function, then that means your function is even, okay? Yeah. Now, graphically, a function is even if it is symmetric about the y-axis, so something like this in this picture here. So like a parabola, if you will, would be like represent like an even function, okay? Now, for a function to be odd, an odd function satisfies this property over here, where if you plug in minus x for x, it's the same as like putting a minus sign in front of your function. So it just makes your function negative, if you will. And graphically, an odd function, its graph will look something like this, where there's kind of a symmetry about the origin, okay? And so for these problems that we have here, we have a bunch of functions given, so maybe I won't do all of them, but I'll try to do some of them. And we're going to check if these functions are even or odd. All right, was there a question just now? Or is that just an accident? Okay, I'm guessing that was just an accident. All right. So let's take a look at some of these functions here. So first, I need to switch back to the pencil. Let me see, how did I do that? Oh, I see, okay. All right, so yeah, I apologize. I'm not used to using OneNote in the browser, as I said earlier. Okay, so I'll do some of these functions. So I guess the first function that we had was part A. And this function f of x is 1 minus 2x squared, okay? So what you want to do to check if the function is even or odd is you want to start by calculating f of minus x, okay? So the way this works is just like how like f of 2, you would plug in 2 for x. So when you're doing like f of minus x, that means you want to plug in minus x in place of x, okay? So here, instead of 2x squared, we have 2, and then minus x in place of x, and then squared, okay? Here, be sure that you're putting parentheses around it. When you put parentheses around it, that will maybe make it more clear that when we square this now, so minus x squared, when you square, the negative goes away. So it's actually just going to be regular x squared, okay? So notice in this problem that when we calculated f of minus x, we actually got the same thing as the original f of x. Okay. So because f of minus x is equal to f of x, that means that this function that we're given would be an even function then, okay? Star is plus.
Hi, I have a question. You have
Yeah, yeah.
minus 2 and minus x. Yeah.
Wait, 1 second. I'm turning the volume up a little bit. Okay, can you say that again?
Okay, you have minus 2 times minus x is supposed to be plus 2x, right?
Okay. I think I see what you're saying. Okay. Oh, 1 second. So when you're thinking of the order of operations, so this power operation comes first before the multiplication. Let me add a little bit to here. So maybe you can think of it like this. So, whoops. I'll just change to black real quick. So yeah, we have minus 2, and then this minus x squared. Maybe it helps if you think of it as minus x all squared is really taking minus x and multiplying it with itself, right? Because when you have something squared, it's just taking that something and multiplying it with itself.
Okay, makes sense now. Yeah, makes sense now.
Yeah, so actually there's kind of like a 3 minuses if you think of it that way. So that's why it ends up being minus in the end then, okay? All right, good. All right, so let's take a look at some of the other parts. Oh, geez. Okay, all right. Maybe I'll take a look at part B next. So part B looks like f of x was x squared plus 4x plus 1. Okay. So we want to check if this function is even or odd, or possibly neither, or even possibly both. Okay. So what we're going to do for this then is we're going to separate. Oh, geez. Okay. It's this again. Okay. So we're going to start by calculating f of minus x. Okay. All right, so again, when you're calculating f of minus x, wherever you see an x in the function, you're going to replace it with a minus x. Okay, so this is what f of minus x would be here. Now in this case, if we square the minus x, it's going to become positive x squared. Okay. Here we do have 4 times negative x, so that's going to become minus 4x. Okay. And then we still have the plus 1 at the end. Okay, so now notice this time that f of minus x is actually not the same as the original f of x. Okay. Because here we have the difference in the minus 4x versus plus 4x. Okay. So this tells us that our function is not going to be even this time. Now, on the other hand, notice that f of minus x, it's also not equal to minus f of x. Okay. Because minus f of x would be putting a minus in front of everything here that we have for f of x. And that minus would then have to distribute to everything. Okay. So what we have here for minus f of x is not the same as f of minus x. Okay. So because these are not the same, that means our function is also not odd. Okay. So because it's neither, well, it's not even and it's not odd, so it's going to be neither then, okay? So this function f is neither even nor odd for part B. Okay. Let's do maybe one or two more. So I just did parts at A and B. So if you guys maybe look at parts like C through F, hopefully you guys can see that decently well. Do you guys want to maybe pick one or two more parts between C through F that you would like to see me work through? Or maybe if you guys are good, just let me know that as well, and we can also go on to another problem as well, okay? So maybe I give you guys a couple of seconds to think, is there something between C through F that you want me to work through? E and F, okay. First come, first serve, so let's do E and F then, okay? Okay. So bring through this one, all right. So in E, f of x is 3 minus 2 times, oh geez, 2, there you go, times absolute value x plus 2. Okay. All right, so let's try replacing x. Oh man, I don't know why that happens. Okay. All right. So let's try replacing x with minus x. Okay, so if we replace x with minus x, we're going to get 3 minus 2 absolute value, and then here, instead of x plus 2, we're going to have like minus x plus 2 then, okay? All right. So then looking at what we have for f of x and f of minus x, okay? Are these the same expressions? Are these somehow equivalent to each other? Okay. So maybe it's a little tricky if you're not too familiar with like working with absolute values, right? So in this case, no, these are actually not the same. That minus sign does make a difference. So this function is going to be not even, since f of minus x is not the same as f of x. If maybe you have something like this and you're not too sure if these are the same or not, okay? One thing that you could do is to just kind of like test this to see if it works. So when I say test this, try looking at like a specific numbers. So maybe like if we compare f of -1 versus f of 1. So like kind of thinking of like plugging in 1 for x on both sides. Okay. In this case, f of 1 would be, I'm going to plug in 1 for x here. That gives you that 3 minus 2 times 3 should be 3 minus 6. So you get f of 1 is equal to -3. Whoops. Okay. Okay. That's a good question. Yes. Okay. So these two are not the same, but if we didn't have +2 in the absolute value, so if you just had like a absolute value x versus absolute value -x, yeah, in this case, they would be the same, okay? So it's really that +2 that really throws things off. Here, just to kind of finish this part real quick, if you were to calculate f of -1, so maybe I'll take what we calculated for f of -x, but just, well, I mean, it doesn't matter either way. So essentially, we want to plug in -1 for the x up here, or plug in +1 for this x. But it'll be 3 minus, geez. Okay, but here it'll be 3 minus, okay, 2, there you go. And then if we plug in like -1 to the x, -1 plus 2 is 1. 2 times 1 is 2. 3 minus 2 gives you a final answer of +1 for f of -1. So here you can kind of see, you can try plugging in like a specific number if you're not too sure. So if we try to test like 1 and -1, you can see that f of -1 is not the same as f of 1. And that will lead you to the same conclusion that's not even. Because to be even, these would have to be equal for all values of x, okay? All right, good. So yeah, in this case, it's not even. And it's also going to be not odd either. Okay. So remember, for odd, the f of minus x is supposed to equal minus f of x when it's an odd function. Okay. But in this case, these turn out to not be equal. And we can kind of just test that as well. So, because here, for minus f of x, that really just means take f of x and put a minus in front of the whole thing. So then really that minus distributes to both terms. So it's like -3 plus 2 times the absolute value of x plus 2. And just comparing what we have for minus f of x to f of minus x, these are definitely not the same. And again, if you're really not sure about that, you can always try plugging in like a specific x values to test it, okay? All right, yeah, so this would be another case where the function is neither even nor odd. So lastly, let's take a look at part F, which was x over x squared plus 1. Okay. So to check if it's even or odd, again, start by calculating f of minus x. And to calculate that, you're just going to replace each x in your function with a minus x. Now in this case, so minus x all squared will just give you x squared. So we have minus x over x squared plus 1, which is the same as minus x over x squared plus 1. So you can pull the minus to the front like that. So in this case, you'll notice that f of minus x is equal to, because notice here this is minus f of x. So minus, and then this is f of x. So therefore, since f of minus x equals minus f of x, that means that in this case, f is actually an odd function then, okay? All right. Is it possible for a function to be both even and odd? What do you guys think? All right, lots of no's. Yeah, basically, you guys are correct. There's kind of one small, kind of silly exception almost. So if you consider the function f of x, which is defined to be like always equal to 0, this is kind of the only case where a function would be both even and odd. Because in this case, if you try to compute f of minus x, there's no x's to plug in, it's just always 0. So you would have f of minus x being equal to f of x. But on the other hand, 0 is the same as minus 0 because the minus doesn't make a difference. So you can also say that's also the same as minus f of x. But so this kind of silly case where f is defined to be like always equal to 0 would be both even and odd, but this is the only exception. So any other function that's not like just plain 0 like this could not be both even and odd. This is the only function that satisfies that property, okay? All right, good. So let's take a look at another problem then. It's 536, okay. All right, so I guess here it's a problem about finding the inverse of a function. So to find the inverse of a function, there's like a certain procedure that you follow in order to calculate the inverse. So what I'm going to do is I'm going to take the function that we're given right now, and I'm just going to replace f of x with y to start with. Okay. And what you want to do in order to calculate the inverse is you want to swap the x's with y's, and vice versa. So that means on the left, instead of y, we're going to have x. And then on the right, these two x's, I'm going to replace them with y's. Okay? Let's see here. Okay, let me try that. Okay. All right, yeah, so we just swapped the x's and the y's, and then what you want to do now is oh wait, sorry, this should be a y then. It's my bad. Good. And then in order to get the inverse, what we now want to do is we want to solve for y again. So from this equation, if we were to solve for y, what we can start with is we can multiply the 3y minus 1 over to the other side first. So we'll have x times 3y minus 1 equals y plus 2. So if we distribute the x into the parentheses, it's 3xy minus x is y plus 2 right now. And I want to get all the y's on one side. So I think what I will do is let's minus y on both sides. And I also want to get everything else to the other side. So since I'm moving the y's over to the left, let's get rid of this minus x, so we're going to add x to both sides as well. So moving the x to the right. So that leaves us with 3x minus y on the left. So move the y over and then move the x over. So now we have x plus 2 on the right. And now on the left, we have a y in both of these terms. So what we can do and what we want to do is we're going to factor the y out from both terms there. So we factor out the y, that leaves us with 3x in the first term. And then we still have a minus 1 remaining for the second part. Okay? And now that you factor the y out, you can divide both sides by 3x minus 1. Okay. So now that you solve for y, if you just replace y with the inverse, okay, then this over here, this would be the inverse function to the original f of x then, okay? Okay, so swap your x's with the y's and vice versa, and then solve for y, and that gives you the inverse function at the end, okay? Okay, all right. Let's look at the next problem. Okay, so this is calculating some compositions here. Yeah, so this problem is asking us to compute f composed with g and also g composed with f, okay? Okay, so let's start with the first one, f composed with g. So what this means, so this is like plugging g of x into f. Okay, so let's see how this works. So g of x is 5 minus 2x. So we're going to plug all of that into the function f. So the way we're going to do that is just like how, like with like f of 2, you replace each x with a 2. So here we're going to replace each x in the formula for f with a 5 minus 2x. So instead of x over x squared plus 1, we replace each of those x's with 5 minus 2x. So that leaves us with this at the end. So this would be f composed with g of x, okay? And then g composed with f will be similar. So this means to plug f of x into g. In this problem, f is x over x squared plus 1. So then to calculate this, we're going to take what we're given for g of x, and we're going to replace each instance of x in this formula with x over x squared plus 1. Okay. So instead of 5 minus 2x, we're just replacing that x with what we're plugging into g. So then that would be g composed with f of x, and I guess if you wanted to rewrite it, you could, because this multiplication by 2, you can kind of think of it as 2 over 1 if you want. So to multiply these, the 2 would multiply into the numerator. So you could write it as 5 minus 2x, and then just over x squared plus 1 like that, okay? All right, any questions about that? Okay. Let's see what we have here. Give me 1 second. I wonder if I can just... Oh, well, okay. Well, let me kind of read this question here. So there's 2 parts of the question. The first part says, let data be the central angle of a circle that has a diameter of 10 inches. And then suppose the arc associated with the angle data has a length of 13 inches. It's asking what's the angle measure of data in degrees. So let me try to draw a picture of what was given. So diameter 10 inches, arc 13 inches. So let's say here's our circle. We know that the diameter altogether is 10 inches. Oh, whoops. Okay, and then we've got an angle data. And I'm just going to kind of draw it at random. I think it'll look maybe something like this. So we got this angle data. Oh, you can't see the question? Okay. Well, basically, it's the question is describing this kind of picture here. So it says we're given an angle data. It says data is the central angle of a circle. Diameter is 10 inches, that's given. And then it also tells us that the arc that is associated with the angle data, so that's referring to this arc here that I'm kind of bolding. So it also tells us that this arc, its length is 13 inches, okay? So given all of this information, what the question is asking, it's asking what is the angle data in degrees? That's what the question is asking first, okay? All right, so who knows how to find the angle data given the diameter and the arc length that we have? Okay, so in order to find the angle data, there is a equation that relates the angle data to the corresponding arc length. So let me write down what that equation is. So it's a pretty simple equation. So I'll write the equation like this. I'll write it as S equals R data. Okay. So in this equation, the S represents the arc length. R is the radius of the circle. And then data is the angle. But specifically for this formula, data is the angle in radians, okay? So let's see what we can do with this equation right now. Okay. In this question, we are given the arc lengths. So we're given the value of S is 13 inches. We also know the diameter is 10 inches. So therefore, we also know the radius would be 5 inches, okay? So if we use this equation that we have, S equals R data, S is 13, R is 5. So we have like 13 is equal to 5 times data. So we can actually solve for the angle data from this equation. Data is going to be 13 over 5. All right, but the solution that we found right now has units of radians. Okay. But the question actually wants to answer in degrees rather than radians. So now we need to know how to convert from radians to degrees. Okay. So do you guys know how to convert from radians to degrees?
You would multiply by 180 degrees, but you would divide by pi.
Yes, that's correct, okay? So data is 13 over 5 radians, okay? And comparing radians to degrees, so pi radians is equivalent to 180 degrees, okay? So both kind of represent half of a circle, if you will, okay? So if we want to convert this into degrees, what we'd want to do is we could multiply by 180 degrees and divide by pi radians. Okay. So I guess that kind of cancels the radian units, if you will. And then that will leave you with the answer in degrees. So it's going to be 13 over 5 pi times 180. I guess I need a calculator for this then. And then the answer will be in degrees. 148.9697. That's better. Okay. So yeah, so we'll round it to 2 decimal places. So it looks like it'll be 148.97 degrees then, okay? All right, thank you. So then that would be the answer for part A. So then the key to this problem is this, I guess, two aspects. This equation that relates angles to arc lengths. And then also knowing how to relate radians to degrees, okay? All right, let's look at part B as well. So let me write out the question because I know it's kind of small. And I don't know how to make it bigger or zoom in, at least not in the OneNote on the web. So now in part B, what we have is we know the central angle of a circle is 110 degrees. So let me draw a picture of that. Control plus button. I guess I can try that. Oh, it's kind of weird though. So let's see here. Well, that's fine. Next time I'm gonna probably, yeah. Okay, so it's fine. So I'll just route out the problem. We're almost done anyway, so it's not a big deal. So yeah, in the question, we're given the central angle is 110 degrees. All right. Also, I guess, well, it's not important, so maybe I'll talk about it at the end. So we're given this angle theta is 110 degrees, okay? Okay. Then it also says the radius of the circle is 8 inches. So given the radius is 8 inches. Now the question asks, what is the length of the arc associated with this angle? So I was using S earlier to represent arc length. So they're asking us what is the length of this arc, okay? So we had this equation earlier, S equals R theta. Okay. And we're given R and theta, so it looks like we can just multiply them in order to get the arc length. Okay. However, remember that this formula only works when theta is in radians, okay? And we are given the angle theta in degrees. So before we can multiply R and theta to get S, we first need to convert theta into radians, okay? Okay. Now to convert to to convert to radians, we're going to use the idea that like pi radians is equal to 180 degrees. Okay. So here the units of degrees kind of cancel. So it's 110 pi over 180. Okay. So this would be the angle data in radians. Okay. And then once we have the angle data in radians, we can now plug it into this equation to get the arc length. So S is R, which is 8, times theta, so 110 pi over 180. Answer will be in inches in the end, so you can maybe use a calculator to calculate all of that, but that would give you the arc length at the end, okay? All right, so I don't have a calculator on me, so if someone wants to calculate that, maybe just let us know, just for the sake of it, what you get. Okay, 15.36 inches. Okay, then 1.92 times 8. Yeah, I think that works out then. Okay, good. Yeah, good. All right, good. So it's 6 o'clock, but I only have one question left for the review. So we may as well, take a look at the last question. All right. Jeez. All right, so yeah, let's see what this question says. Let's see if I can. Okay. So here the question says that we have a bike with wheels of a radius 2 feet. And we've ridden the bike down a 10-mile trail in a time span of 35 minutes, okay? So maybe I'll just say we traveled, 10 miles in 35 minutes. So that's all the information that was given. So then part A is asking for the angular distance. In radians. Traveled by a point on the wheel of the bike. Oh, okay. Traveled is spelled with one L, okay, apparently. Okay. Traveled by a point on the wheel. Okay. Okay, so when they ask for the angular distance, they are essentially looking for data. So for this question, we can actually use the same equation that we had earlier. S equals R data. Okay. Now this time what happens though is that I guess our wheel has spun around more than once, okay? So it's probably made like multiple revolutions during this time. But the total distance that a point on the wheel has traveled would be the 10 miles that you traversed on your bike. So we're going to have S set to be 10 miles for this first part. Then we also know that the radius R is 2 feet. So using this information that we have, we can calculate the angle data, the angular distance that has been traversed. So let's plug in the numbers that we have right now. S is 10 miles. R is 2 feet. And then that's multiplying angle data. So that means data is going to be 10 miles divided by 2 feet. Okay. Now, in order to complete the computation, we are first going to have to either convert the miles to feet or the feet to miles. Okay. But either way, we need to make sure that these units are consistent before we can actually come further. Or really, we just need to answer in radians. So to do that, we need to, okay, that was weird. So we need the units to be the same first, okay? So we can use the fact that 1 mile is equal to, I believe, 5,280 feet. Okay? If I have that right. So then when we do that, the units will cancel, which is good. So that's going to leave us with data. It will be 10 times 5280 over 2. And then the units will be in radians at that point. And if we just crunch the numbers here, what is that going to be? 2, 6, 4, and 2 zeros. Okay. So then that would be the answer to part A in radians. Okay. All right. Let's see here. So next part B is asking how many revolutions did the wheel of the bike go through on this trip? Okay. Okay, so the idea of this problem is 1 revolution corresponds to, so to complete like 1 circle, that corresponds to an angular distance of like 360 degrees. Because you know that to go full circle, you need to traverse 360 degrees to do that. And 360 degrees is the same as 2 pi radians. Okay. Since 180 degrees is the same as 1 pi. Okay. So to get the number of revolutions, what we can do is take the angular distance that we calculated in part A. So this is how many radians our bikes went through. And then we're just going to say that 1 revolution is 2 pi radians. Okay. And then that's going to give us the answer in revolutions then. So 26400 over 2 pi revolutions. So maybe if someone wants to help us out again, and if you want to calculate this number real quick on your calculator and let us know what you get. Okay. Oh, okay, all right. 6.8 or 6.9, maybe 6.9 if we round it up. But then this would tell us the number of revolutions that the wheels went through, okay? Okay, all right. We'll go with 6.8 then. All right, good. All right, let's take a look at the last two parts. So part C, okay, part C asking for the linear speed of the bike during the trip. And part D is the angular speed, okay. Okay. So linear speed just refers to, it's just speed in the usual sense, you could say. It's just like how fast was the bike moving at, okay? So we know that so we know that you traveled 10 miles in 35 minutes. And we can get the speed just by doing distance over time. Okay. So V is going to be, the speed was, we traveled 10 miles. And the, what was it again, 35, I think is what I said. Yeah, 10 miles in 35 minutes. So just 10 over 35. I guess you could say that's 2 over 7. And then I guess we could leave the answer as miles per minute. Let me see if, did it say what units to use? Oh, it asked for per second and next part. Okay, so for now, it didn't specify the unit, so this would be good enough. So the linear speed was 2/7 of a mile per minute. That's how fast we were traveling, okay? So then lastly, part D was asking what's the angular speed? I guess maybe angular speed of a point on the wheel of the bike. And then both radians and revolutions, okay. So then there's an equation that relates linear speed to angular speed. So this equation says that the linear speed v will be equal to r times, okay, and then here, this is a Greek letter. It looks like a W, but it's actually a Greek letter omega. It's a lowercase omega. If you guys are somewhat familiar, this is like a, wait, is that a capital omega? No, is that, maybe that's, well, okay, whatever, I don't remember. This is a Greek letter omega. It represents the angular speed. R is still the radius. And then V, as before, was the linear speed. Okay. Ooh, okay. Now, so this equation is kind of similar to it's analogous somewhat to the S equals R data formula that we had before. And if you remember in this formula, the data was always in radians for this formula to work. So likewise, for this formula that we have relating linear speed and angular speed, in this formula, the angular speed omega must be units of radians, I guess radians per unit time. That unit of time could be like seconds or minutes or whatever. But it has to be radians in particular, so it can't be like degrees or revolutions or anything like that. For this formula to work, it must be radians per unit of time, okay? Okay, so let's see what we have right now. So we calculated V already as miles per minute, 2/7 of a mile per minute. And from the problem, the radius, so that's just referring to the radius of one of the bike wheels, that was given to be 2 feet in the problem, okay? So in the equation, we have V is R times omega. So we have 2/7 of a mile per minute equals the radius of 2 feet. And then times the angular speed omega. So to solve for omega, we want to divide both sides by 2. And dividing by 2, maybe I'll write it as multiplying by 1/2 instead. I think that will look nicer. Okay. And then we have miles on top. On the bottom, we have both the minutes. But since we divided by 2 feet, we also have units of feet in the denominator as well. Okay. Okay. So that leaves us for the angular speed. We can at least cancel the 2s, so it's 1/7. And then we have these kind of units which are kind of strange, I guess. Miles per minute per feet, if you will, or foot. And so to get the answer in terms of like radians per unit of time, again, we need the units of distance to be consistent. So we have miles and feet. So what we need to do is we need to convert that. Okay. So to do that, let's do the same conversion. That 1 mile is 5,280 feet. Okay. So when we do this, all the units of distance will cancel. So that's going to leave us with omega to the angular speed to be 5,280 over 7. And now their units will be in terms of radians per minute. Okay. And I think that would round to 754.29 radians per minute. Okay. Now this is in radians per minute. Okay. In the wording of the problem, they wanted it in radians per second, as well as revolutions per second. So let's just talk about those two real quick. All right, no problem. So if you want it in radians per second, you would just need to continue doing some unit conversions. So to get it into seconds, you would just say that 1 minute is 60 seconds. Okay. So we'd have to take this number 754.29 and divide it by 60. And that will give the answer in radians per second. Okay. And then just lastly, if you wanted it in revolutions per second, then what you would do is just use the fact that 1 revolution corresponds to 2 pi radians. Okay. So to get revolutions per second, it would be 754.29 over. And then we have 60 times 2 pi, so maybe 120 pi altogether in the denominator. Oh. That would be in revolutions per second, okay? All right, we'll go ahead and I guess end the review at that point. It was a little over time, but that's okay.